Hey, welcome back to the shop. Today I have a mail call project. Somebody on German online forum asked me if I could help him out with some shaper work on parts he machined. These are plain brass bushings for a surface grinder, for the spindle of a surface grinder. Quite massive. They have about 40mm internal diameter and a big old acne thread on the other end. I looked at the drawings and the photos he sent me, and sure, I couldn't do it, and he sent them over to me. I made sure that he allows that I film the process of this project, and there we are. Let's bring the camera in a bit closer and see what we're up to. Okay, these are the brass bushings. I have 4 of them here in the shop, and as you can see, they are bored. The internal diameter is not finished yet. They are threaded on this end, and they have 3 ribs along the big diameter here. And the problem is the area between the 2 ribs. As you can see, he pre-milled it, but he needs this diameter to be round and of a certain diameter. So you could do it on a milling machine by rotating it that way and running an end mill back and forth all the time. Would be a perfect CNC part to be run on a 4-axis CNC machine, or on a 3-axis with a rotary axis. But I don't have a CNC anymore, but I have a shaper, and I can clamp it on an arbor. He supplied me with an arbor that fits these parts and that I adapted to my rotary table, and I can shape along the length and turn the part at the same time with the rotary table. And that will give me a round outer diameter, and I can machine up to the webs, to these ribs along the length. They are not finished yet. They should be 6mm, but they have about 1 or 2/10 of a millimeter stock allowance on them, and he will machine these ribs to width by his own on the milling machine. He will cut them to width and slightly undercut the diameter. So I'm only going to machine, take a blue pen, I'm only going to machine from here about to here, from here to here. Same for the other 2. Like this. We will not touch these 3 ribs. And the outer diameter needs to be 48mm. He rough milled them to about something like 51.5, something like that, 52 almost, but that doesn't matter. We will cut that material away anyway. So quite an interesting job. You don't see a lot of people doing round parts on the shaper for whatever reason. Okay, off camera I did the first 2 of these bearings, and as you can see, I machined the round part between these splines already round, and I hit my diameter a bit under size, at least with calipers. And that's fine. As far as I understood, these areas here are clearance. The bearing itself sits on these splines. He will check this up after I send them back to him and machine the outer surface of these splines round to a given diameter that sits in the bearing seat of the spindle. At least that's what I understood. And the area between these splines is only for clearance to get the oil where it needs to be. But still I want them to be somewhat nice machined. I could just rough cut them and yeah, but no, I'm not going to send something out that's really rough cut. And this is how I start, and this is how they look later. And as you can see, there's quite a lot of material on. There are about 2 millimeters in thickness of additional material that we need to hog off on the shaper. So let's go to the shaper and I'll show you my setup. Okay, I have the rotary table at the most outer end of the table, and I have my arbor. It's aligned in both directions to the travel of the ram, and I make sure that it's clean, so we don't touch anything up. Make sure it's clean. Got some lube on there, because the fit of the bearings on the arbor is pretty close, so some oil doesn't hurt. When in doubt, use lube. We make sure that our bore is clean, and also we make sure that this bottom surface here has no burrs, and it has. So we just take a file and run it flat over the surface. Get it on, and I have to crank the table all the way over so I can get the bearing onto the arbor. And as you can see, this is a pretty close fit. That's fine. And I put it on the wrong way. They need to go on this way. There we go. Then we take our nut. And our 2-pin spanner wrench. And tighten it down on the arbor. That's good. And now we can take a cut. Crank this back to the center of the machine. Okay, a lot of people are always curious about the shaper tools I use. For roughing on this project, I'm going to use this straight 90-degree tool because it has a very massive shank and doesn't chatter. For semi-finishing, I'm using a 40-degree round nose straight tool. We have to put a second bit behind it because the shank square, the cross section of the shank is pretty small and is prone to chatter. And for finishing, I'm going to use this parting tool with a flat top. So we will cut not really a true round workpiece, we'll cut a faceted a polygon. Let's take one of James' notepads and I will show you what I mean by polygon. We're not going to make a round surface, we're going to cut something like this with a lot of flats. And if we come back with some fine emery cloth, we can somewhat equalize this and make it semi-round. That's for the purpose of this is way good enough. So let's go to the shaper. It doesn't need to be 100% centered. It's eyeballing is good enough in this case. Then we take our heavy-duty roughing tool and we bring it in here. Then we need to set the height correct so we don't hit our rotary table with the screw of the clapper box which holds the tool. If you hit the rotary table, this is really bad, and I know this because it happened. Okay, now we can drop the tool down and clamp it. Okay, now I need to touch off with the tool somewhere to know how deep I have to cut, and the easiest thing is to use the nut of the arbor. The nut is 47mm in diameter and our finish diameter needs to be 48. And I want to have some allowance for a finishing cut. So I take a 1mm gauge block and set it on top of the nut, and that gives me 47, that's the diameter of the nut, plus 1mm per side of diameter. So if we touch off and take a cut now, we will end up with a diameter of about 49mm. To get clearance. And now I can touch off with the gauge block below the cutter. There we go. We can zero our dial and retract the tool. Okay, now I will just plunge down with my tool until I hit my number on the dial, and then I will crank the rotary table. And I forgot something. Because of the long overhang of the arbor, this is prone to chatter, at least while we are roughing. So I have a screw jack down here, and I take a V-block and just push it lightly with the screw jack up against the arbor to dampen the vibrations. And this is not perfect because the V-block is resting on the arbor nut, which is not 100% true running. But for roughing it doesn't matter. When we do semi-finishing and finishing, we will take the V-block out and let it hang freely in the breeze. Let's retract the tool. Okay. Turn the rotary table. Okay, first section done. Now we move over, skip the spline, and do the next area between the splines. Just a rough measurement with the calipers, and this is pretty good what I see. We have, wait for it, We have 48.8, so we have 0.8 millimeters to go. Now we'll do a semi-finishing pass with the narrower straight tool without the support of the V-block, so we get a true running diameter. Let's get the V-block out there. Don't need that anymore. This is already the last of the bushings. I did the other three prior filming, so I get the process dialed in. And I had some problems with chatter and catching of the tool in the brass and so on, and that's all stuff I don't want to have on camera because it gets annoying for me. If I have problems with a machining task, I want to concentrate on the machining task and not be bothered with filming. Okay, right now we're semi-finishing, and I already did two of the circular areas, so we're cranking over to the last one. Retract the tool so we don't fudge it up. Get everything in alignment and drop down the tool and do another cut. There we go. Now we can change to our parting tool, clean up the splines, or almost all the way up to the splines, leave some stock on there, and finish the diameter of the round section. And as it looks, I have to recharge the batteries of my camera. Okay, I changed to a parting tool, and now I'm going to approach via the rotary table the cutter up against the spline and back it off slightly, like this, so we get some stock allowance, so he can finish the splines later with the milling machine. And now it will just plunge down until I hit my diameter and slightly rotate in. Okay, that cleaned up the corner about 3/10 of a millimeter up to the spline, so this is good enough. And now we can concentrate on the outer diameter. Finish this. Let's touch off on the surface with the parting tool. Well, stop. First we have to remove. I inserted the V-block and the screw jack while I was picking out the corners because it was also prone to chatter. But now, finish cutting, we don't need it anymore. And we will take a measurement again before we advance our cutter, so we don't fudge it up. We have about 0.35 millimeters to go, so we will feed in 1/10 of a millimeter, take a finish cut, and then do a final measurement and take it to final size. Let's turn. Okay. Okay. This is semi-finished, or almost finished. Now you can see the facets of the parting tool that I used to cut the final diameter. Okay, we are done, and now we can take it off the arbor. There we go. Isn't that quite a nice surface? Yeah, I think so. Okay, let's go to the bench and hit it with some emery cloth, and we're done. Row at the vise, bench-wise. I'm just going to hit the surfaces with some 180 grit emery cloth to break the crowns of the shaper marks slightly, just to make it look nice and make it look more uniform. There we go. Somewhat even finish. Now we can hit it with some grey Scotch-Brite, superfine Scotch-Brite. Okay, these are the 4 bushings, and they are all done. Came out pretty good. They are not super precise in diameter. This one is 48.505, sorry. This is 0.05 of a millimeter undersize. This is about 0. And yes, I'm just measuring with the calipers because it's not super accurate. And this is also somewhat on size. So, should be good enough for this purpose. Was quite an interesting job. You don't see the shaping of a rounded surface very often done. And it's surprisingly effective and fast, as you could do it on a 4-axis CNC milling machine or on a manual milling machine with a rotary head or dividing head. But I think this is one of the rare occasions where the shaper is faster. So, thank you for watching. See you next time.